This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Listen up, software engineers! When was the last time you proposed a product change that was really listened to? How often does your code ship to production? Same day, within minutes? When was the last time you actually wanted to go to work? At Ultimate Software, this could be your new normal. And with offices in Florida, Georgia, and California, what are you waiting for? Visit ultimatesoftware.com/careers today and start making a difference tomorrow. Ultimate Software. People first.
Welcome everyone to Software Engineering Radio today. My name's Kim Carter. I'll be your host for the day. Today we've got Scott Piper. Scott has a decade of experience in cybersecurity, having previously worked at the NSA as a developer for commercial security products and as the director of security for a startup. He now focuses on improving the security of AWS environments as an independent consultant. Welcome to the show, Scott.
Hey, thanks for having me.
We've had shows on the modern cloud-based platform in 2014 with Adam Cockcroft. That was show number 216. And we've had a show on Docker security with Diego Monica. That was show number 290. There's some relevant articles from IEEE Computer Society on today's topic, cloud security and security challenges in cloud. Today we're going to be discussing cloud security. I'm just going to start off with some basic questions. When moving to the cloud, our servers, compute, storage, and many other physical aspects have now become abstract concepts. As a software engineer, what thoughts do you have on how we need to change our approach to security when moving to the cloud?
A lot of it, honestly, it's a lot of the same concepts, but you just have to learn how to apply them slightly differently. So one of the things that AWS and other cloud providers talk about is kind of the shared responsibility model. And so what you have to understand going in is there are some things that your cloud provider will take care of for you, and there's some things that you still need to take care of for yourself or need to focus more on. And so some examples of that is, you could use different types of services that, for example, like load balancing services might do SSL termination or something like that for you. So you're not going to have to worry about, updating OpenSSL on those different services. However, you still need to make sure that any endpoints that you have behind those, that you still look for and take care of any type of SQL injection or cross-site scripting or other types of issues like that. So it's just kind of understanding where your responsibilities lie and where the cloud vendor's responsibilities lie.
Yeah. Can you explain what the shared responsibility model is and how it's supposed to work and what sort of misconceptions are around it?
Yeah, so it basically just means that there's going to be some things, for example, the physical security of the environment. You don't have to, you are not going to be responsible for trying to take any precautions to try and protect the, actual physical data centers of your cloud provider. However, the software that gets installed onto the instances that provider provides to you, you still have to take care of that yourself. And so you have to understand for the different services that you're using from them where your responsibilities end and where theirs begin. And so it becomes just important to try and make note of that as you're going through and setting things up and determining how much time you're going to end up spending in different areas.
Yeah. So in terms of the shared responsibility model, what aspects of security is the CSP or a cloud service provider actually responsible for?
Again, it's going to depend on the different services that you're using. So, for example, if you're using, AWS's EC2 service, that's going to be basically providing you with a VM instance that you can install software on. And so you're going to be responsible for updating the operating system on there and updating any of the software that you're running on there. But if you're using something like AWS Lambda, that's going to be a service that all you're going to be doing is running code on there. So that's going to be And so in that case, you're not going to be responsible for the operating system or updating, some of the libraries that happen behind the scenes, but the libraries that you put on there yourself or the code that you put on there yourself, you're going to have to make sure that you update that.
So I guess due to the scale of the size of most of the large CSPs, and like they generally have their own security teams and that sort of thing, they do actually take care of a lot of stuff that we used to have to take care of ourselves, right, before the migration to the cloud.
Exactly. Yeah. So I mean, there's a ton of different service offerings that they're providing, and like I said, one of the biggest ones that's just going to be across the board for all the different services that you're using is just going to be that physical security that you're not going to have to worry about. So having a data center and having potentially guards manning it 24/7 and video surveillance around it, and the processes and procedures for destroying hard drives that have come to end of life and things like that. Your cloud service provider is going to take care of those for you. But then when it comes to things like patching and upgrading, there's kind of a give and take, and you have to realize which services you're using is going to be dependent on which of those responsibilities you have.
So what do you see as the highest risks in handing everything over to CSPs?
I think the biggest danger is just the realization that in your historic data centers that you controlled and maintained yourself, one, you potentially had more visibility into what happened there, and you had more ability to set your own rules for yourself. Whereas when you move to a cloud service provider, they're setting all of those rules for you, and in some cases, they might not be the same rules or as good rules as you would have liked. However, for the most part, a lot of the rules that they've set and practices and procedures that they're following are going to be at a higher level than you would be able to maintain yourself. And so that's one of the big things. Another big issue is just that historically in your own data center, if something was to be exposed publicly to the internet, that was probably going to require firewall changes, which might mean someone actually having to physically go to a data center and potentially plug things in, physically manually plug things in between boxes in order to make that happen, or at least physically go to that data center in order to log into the console and make those changes. And so that's kind of the biggest difference is now with the cloud, things can get exposed publicly just with a click of the button. It's very simple. It's very easy. And so, with that ease comes those problems as well. And that you can accidentally make these changes, or it becomes so easy that, someone that doesn't understand what they're doing could potentially make those things publicly accessible. And so as an example of this, we've seen that, every week a new company comes out that's been a victim of an S3 bucket on Amazon that's been publicly exposed because there's a single button that you click on there just to say make this publicly world accessible, and it becomes available to everybody.
Yeah. I think your project FLAWS is a great example of how developers and engineers can actually get better at doing this stuff as well, which we'll discuss closer toward the end of the show. So here's what we're trying to protect as software engineers and the organizations we work for changed much from the exodus of on-premise to the cloud, and if so, how so?
I wouldn't say that it's been so much a change of on-premise to the cloud, but just a change as to how kind of everybody is approaching a lot of software development and operations these days, and specifically that they're becoming more blended. And part of that is due to the cloud making that easier, because now you can acquire servers with clicks of the button or with just scripting it and writing code to accomplish that. So that becomes a lot more blended with the DevOps movement that happening, and a lot of the reason why the DevOps movement has happened has been because people's time has been freed up in order to accomplish this blend of activities as opposed to having to be siloed into specific skills. Yeah.
So we're still trying to protect our own customer data and that sort of thing, right? So that hasn't really changed with the move, has it?
No, I mean, a lot of your same goals and a lot of your same practices, also apply to the cloud in different ways. Just kind of the biggest things around it have really just been, now you can use things like, Terraform, CloudFormation, or other type of scripting technologies in order to bring up new instances, change firewall settings, and be able to make those changes via simple scripts and simple CLIs.
So how do we need to adjust our thinking so that our security focus is in the right areas, and how should our focus have changed?
I think it mostly becomes, now that there aren't certain things that you need to worry about because of the shared responsibility model, that frees you up in order to, kind of view things, to be able to do different tasks. Additionally, you're going to have APIs that give you insight into things. So whereas with physical data centers, someone actually might have had to follow cables around in order to figure out what's plugged into what and what can actually communicate with what. Whereas in the cloud environment, there's API calls that you can make that can tell you what things are actually able to talk to what. And so because of that then enables you to create new tools and create scanners that can do this. So whereas previously, it might have only been a task that you would go about doing quarterly or something like that to try and do a physical assessment of some sort of and understanding what was connected to what. Now you can do these things hourly or every minute, or be able to get alerts when any of these changes are made. So that's kind of the biggest difference there. Is I think that it's able to move you forward by enabling you to accomplish some of these things that you couldn't accomplish previously.
What are the benefits of cloud computing? Like, what are our assets we need to be considering when threat modeling the cloud and the suitability of various providers?
A lot of it becomes pretty similar as you had been doing in your data centers.
So I'm thinking things like productivity, competitive advantage, control, customer data, reputation, and that sort of thing.
Yeah. A lot of these are all just going to be gains. I think a lot of benefits there. Your productivity increases infinitely, because now you don't have to worry about trying to acquire new systems or make sure your HVAC system is going to be able to work with this environment. You're able to just acquire new systems, and additionally you're able to leverage services that are provided for you. So for example, some of these cloud providers provide an Elasticsearch managed Elasticsearch cluster for you, and so you no longer have to try and maintain that yourself. They also provide a lot of database capabilities for you for performing snapshots or performing backups of the data. So again, these things are taken care of for you.
Cool. So we're just going to move into a risks and a countermeasures section. I often receive questions from software engineers like, as a software engineer, do I really care about network security? And network security used to be slightly less of an issue for software engineers than it is now. Network security used to be primarily the network administrator's responsibility. And now that our infrastructure and our networks are exposed by code with infrastructure and configuration management tools such as Terraform, Ansible, Docker, and others, what are your thoughts around the responsibility of network security now falling in the laps of software engineers?
I think that it becomes blended a lot of times now, that people have to have both of those skill sets, and so you can't really be as siloed into one of those categories as you used to be. And so you have to understand, what are the impacts and how to use some of these different tools so that you can, basically be able to move faster and accomplish those different things that the cloud enables you to do. So an example of that is, being able to stand up new services can be done, much faster in a cloud environment, whereas previously you had to basically talk with your network engineer and make sure that different ports and services could be opened, and potentially you had to work around restrictions and limitations of some of those devices that you might have already had in your environment, and reorganize some of your subnets and things like that, depending on what you were trying to accomplish. Whereas now that can be done much faster, and really you're not going to be as limited as you were a lot of times with your historical environments.
Yeah, we also had a show with James Turnbull around Terraform. That was show number 289. I work a lot with AWS, which provides a security abstraction model. We can create objects like VPCs, security groups and roles, ingress and egress rules, access control lists, security roles attached to instances, roles consisting of sets of profiles, etc. Then we have another abstraction layer with tools such as Terraform, which allow us to build these resources declaratively rather than imperatively. This allows us to conceptualize and build what we want without understanding low-level constructs, such as firewalls, IP tables, for example, how to configure Cisco appliances and those sorts of things, and where to put these in our network topology. This seems to dumb the skill set down a little bit of software engineers. It also allows programmers to become network engineers in a sense. Do you see this as a step forward or a step backwards, or potentially both, and how so?
I see it as a step forward, just because, now you're not going to have, some of the same, limitations that you had previously, and some of the, I guess, inefficiencies that you had previously, whereas, you might have had to communicate with a whole lot of different people, and it was potentially on what you're trying to accomplish. It could have been big ordeals in your organization to try and open up different ports for different reasons. You were limited in perhaps the number of IP addresses that you had that were publicly accessible, and so now a lot of those restrictions are removed from you, so that you can really accomplish a lot more, a lot faster. It does present dangers, though, that because you are moving faster, that now it does open up a lot of those new risks to you, though.
Yeah, the way I said is we're actually leaving some of these deep specialities up to the security teams and networking teams of the CSP, so we're not having to think about them so much. But like you say, that does open up new risks and potentially new holes in the a lack of understanding around the engineers.
Correct, yeah.
So as customers of the cloud, we have little visibility of the internal workings or implementations of the infrastructural abstractions provided to us. Trust is a core concept that we are yielding to our providers. All software has bugs, right? So how can we be sure that our chosen CSP is fixing their bugs quickly and not exposing us to undue risk?
Yeah, so that is one of the dangers with cloud environments, but I also view it as just kind of a risk and danger that you have with any service that you're using. So you might imagine if you're using the Windows operating system as your base operating system. In that case, you're relying on Microsoft to maintain patches for that system, and so in kind of the same way, your cloud provider, you're relying on them to be patching potentially operating systems that they're running for you, or potentially some of the other services that you're running for you. So you always do have those risks to some degree, and additionally, previously, you might have been using some type of data center where you were leasing space somewhere, you were leasing racks from them. So again, you have kind of those, potential lack of visibility into some of the actions they're doing there for you.
Do you have any sort of concrete examples around how we can get more visibility into the internal infrastructure, or whether it even matters? I mean, what are your thoughts around that?
Yeah, a lot of the cloud providers, they do a very good job of trying to hide that from you, and so it becomes difficult or impossible to know what's happening underneath those abstraction layers that you can't see. In some ways, you might be able to try and try and leak some of that information to yourself, but it's really not something that you should rely on. Basically, they've provided that abstraction to you, and they can change what's happening underneath at any time. And so because of that, it doesn't make a whole lot of sense for you to try and understand what's there if it potentially might change underneath you. As long as you're still getting the same service, and as long as you're still able to use those abstraction layers and make kind of your core base assumptions about what's happening underneath, you don't really need to worry about what's happening, at potentially like a network layer, or at a lower operating system layer or something than what they've provided and exposed to you.
Yeah, the way I think about it is that we're trusting on their deep securities, their deep specialities in security, and what it does is it actually moves our own focus of our development teams to application security more so. Would that be your sort of take on it?
Yeah, exactly. Previously, whereas you might have needed to be an expert in, all sorts of different things, and you needed to make sure that, you were maintaining patches of firmware and things like that, that now, that relieves some of that burden from you.
Are catastrophic data loss more of an issue in the cloud than it was on-prem due to the CSP customers just believing that the CSPs will take care of it and occasionally failing?
There have been a lot of news reports of these different situations in which people have exposed data that they shouldn't, and they happen to have been using different cloud providers, and I'm not sure, and I don't think it's entirely due to the cloud providers. In some cases, some of the user interfaces that they've had have been a little bit more confusing. They've made a couple things, easier to do than they should have done previously. However, it's not, a direct failing of them in the sense that, it wasn't the cloud provider that opened up this access. It was the customer that opened up, some of this different access. However, it is kind of on the cloud provider to make, those menus as understandable as possible, so that the customer understands the implications better of what they're doing. And I don't think that that's probably always been the case, that the customers haven't really realized that for example, that they're opening an S3 bucket to the world and exposing it to everybody. One of the prime examples of this is AWS. When you open up one of these S3 buckets, one of your options is you can expose it to everybody, or you can expose it to authenticated users. And so that was the language that AWS used, was they said authenticated users. And a lot of people took that to mean that it was users of their own AWS account that they were opening this up to, and so people within their own company. What they didn't realize is that authenticated users to AWS means anybody in AWS that is authenticated. So at any other company or any other AWS account, as long as they had authenticated in, they could access these S3 buckets. And so that was a big failing of one of the cloud service providers in providing an understandable menu to them.
Yeah, that's an interesting one, because I think if I saw that, then I'd immediately be thinking about defense in depth, and I'd be looking at that, and my first thoughts would be just what you said there, and then there has to be another step in order to provide extra authentication to that specific bucket.
Exactly. And I mean, there are a lot of tools now that can help with, auditing, for example, some of these misconfigurations like publicly exposed S3 buckets, which, these tools, they can't alert you and say this is, absolutely critical, this is a thing you need to fix, because there are obviously, reasons why you would open up an S3 bucket to be publicly exposed like that. For example, a lot of websites are hosted as S3 buckets. My own personal website for my company is hosted as an S3 bucket. And so you can't, immediately assume that just because it's public that it's bad. There are legitimate reasons for doing it. But then things that you can do to try and, implement defense in depth there is you can, potentially encrypt that information that you're storing there, so that even if it was misconfigured such that this was publicly exposed, that an attacker or anybody else that came across that data would only have access to encrypted data. And so, those are some of the precautions that you can try and take.
Have you got some examples of how we can provide that sort of encryption?
Some of the different service providers themselves, they'll provide different capabilities for performing that encryption for you. So AWS with its S3 buckets, it can accomplish some of that for you. However, there's always the option that you could take to encrypt it yourself with some type of other tool or free third-party tool that exists out there. So that's kind of one of the benefits and frustrations of the cloud, is that there's always going to be many of these different options for you to take. You can either go all in and continuously use more and more of the different cloud service providers offerings, which has the kind of difficulty or frustration that it's continuously locking you into that cloud provider, making it more and more difficult for you to switch cloud providers, or increases the risk that if anything were to ever happen to that cloud provider, that could be more of a greater impact to your business if you're heavily locked into them, and for example that your cloud provider goes bankrupt or some other type of incident happens to them. Or you could go the other route of just using all of your own tools and using the bare minimum of what the cloud service provider offers. And so that reduces that lock-in, but at the same time, it also means that you're not going to be able to, move as efficiently as you would if you were to use all the different cloud service providers' offerings.
Yeah, it's a real balancing act, isn't it? I mean, what are some of the things that we actually have to weigh up there?
I mean, as an example, I mentioned previously, like the Elasticsearch clusters. There are offerings for that from some of the service providers, and so again, another kind of frustration that you can run into is if you're using one of those services, you really become more and more dependent on that cloud service provider and how they're running it for you. There might be ways in which they will be unwilling to configure it that you might be able to configure it yourself. You might not have access to certain logs or a visibility into resource usage that you would have otherwise if you were running it yourself. And so those are some of the difficulties that you can run into. But at this point in time, I mean, there's all sorts of different cloud service offerings. AWS just had their big conference of the year called reInvent, in which they announced a number of new service offerings. And so it becomes very difficult even to just keep track of what all they're providing. I think a lot of people, when they think of the cloud, all they're thinking of is that basically they can run some VM up there. That's what is being granted to you, is the ability to SSH into a system and install your software on there. But nowadays there's a whole variety of different service offerings that exist in addition to different queuing software, different database software that's all being managed and run for you if you want to.
So I want to talk a little bit about how we can evaluate if using any given CSP is going to provide a high enough level of security for us and our customers. So we're going to discuss techniques we can use to compare different CSPs' offerings and whether or not they fit for our purpose. So feel free to mention any that you think of as we work through the following list. What are your thoughts on keeping signed audit logs on UIs and APIs?
I leverage those heavily in a lot of the detections and monitoring that I do, just because you can see not only does it give you the insight into what has historically happened in your environment on purpose from your own employees when perhaps they were starting up new instances, and so this can be helpful to the billing department to understand who was running these new instances and gives insight into when those happened and you can kind of correlate that back to why that happened to some degree, but then it also is very important for being able to detect potentially attackers in your environment, and so this is where logging becomes very important, is seeing some of those access denied. So not only being able to see what did happen in your environment, but also being able to see what was attempted to have happen in your environment. And so that's where a lot of that logging can also be useful. For example, if you've implemented least privileges across your different users that you have in your environment, and someone started trying to use services or access resources they didn't have permission to, there could be legitimate reasons for that, but it also could be because perhaps the credentials of that employee were compromised, and an attacker was trying to look around and investigate inside your environment.
Yeah, there's quite a few tools that can help us there as well, and we're just going to talk a little about those closer to the end of the show. So AWS has CloudTrail, right? I guess that's what you would primarily use for audit logs?
Correct, yeah. So AWS has CloudTrail, which is going to record all the different API calls, and it gives you information about the action that was taken. For example, it's trying to spin up a new EC2 instance or creating a new S3 bucket, and it tells you who did it, tells you when, tells you whether or not they had multi-factor authentication when they were trying to perform this action, but it also has some limitations. And so some of those, for example, is it doesn't give you insight into the data level actions that occur. So as an example, you could see that a new S3 bucket was created, but you could not see what data was read from that bucket or written to that bucket. AWS has recently made an option for you to get some insight into that, but historically that's not been visible to you. Additionally, you could see that a new EC2 instance was created, but you could not see who SSH'd into that instance. You could not see any of your logs from your different services that were running on that instance. So it doesn't give you that type of visibility. Additionally, CloudTrail has always had a 15-minute delay to the recordings of the logs that it does, which means that you can never have true real-time recording or monitoring, alerting, and potentially remediation of things as they happen. You always have the situation where an attacker, if they started doing an attack of any sort, they had 15 minutes where they knew that they would that the defenders would be completely blind to any of that attack. AWS has recently kind of made some changes via what's called CloudWatch logs, where you can get some insight into some of the CloudTrail data, but you still don't get all of the insight into what's happening with that CloudTrail data. You still have to wait that 15 minutes to see the logs when they appear in your S3 bucket, which is where they're recorded to.
Security is everyone's problem to solve and a responsibility to understand. At the O'Reilly Software Architecture Conference, we look at how an understanding of threat and risk can help teams to think broadly about security issues and solutions. Join us in New York, February 25th through 28th. Visit softwarearchitecturecon.com to register and save 20% by using code SER.
Yeah, so for finer grained things like you said, who is actually SSHing into your a VM or whatever else, like basically just finer grained events. What do we use for that? Do we have to set something up on the actual machine?
Yeah. So on if it is for monitoring SSH logins, you're going to have to set something up on that system to record that. And so AWS, for example, they do provide an agent that you could run on that system. However, you could also run whatever other agent you have out there, whether it's Logstash or
Monit or something like that.
Yeah,
something
exactly.
Like Monit,
any other type of monitoring solution you could set up there. But again, it's going to be a thing that you're going to have to know that this is where a limitation of AWS's responsibilities, changes. Whereas this is a thing that is happening on the surface itself, and therefore, that's going to be your responsibility to do that monitoring.
So how many CSPs are encrypting all comms between their servers and their other components within their data centers, and also with their service providers? Can you think of any?
So that is one of the concerns, as you mentioned earlier, about those layers of abstractions where I don't think the different service providers have said, or at least not given specifics in terms of, where all they're doing that potential encryption. Are they doing it, within the data center between, different machines? Are they doing it, between different regions that they have? So as an example, like AWS has the concept of availability zones where you have US East 1 basically encompasses more or less the entire US Eastern Seaboard. So you don't know, between the different cities, is that data being encrypted? I don't think they've ever made those claims, or you'd have to try and dig through a lot of documentation to try and find that out.
Yeah. So what are your thoughts on how we can actually improve that and potentially safeguard ourselves from eavesdropping and that sort of thing?
Yeah, so again, this is a thing where you could set it up yourself, where you could set up, mutual TLS authentication between, all of your different services. There are, some areas between these different cloud service providers that you can hopefully make some assumptions. For example, specifically within, what's called your VPCs, that's going to be hopefully encrypted between there. But again, it depends on how much you really trust that the cloud service provider is really accomplishing all of that for you.
Yeah. So between the likes of our serverless technologies and that, do we have any show of of providing encryption?
I think the only the only thing that we do know is that so far, I haven't heard publicly about anybody, exploiting that in any way. And I would imagine that would be, a big news event if you did find out that, someone was able to sniff some of that traffic and use it in, different ways, or if they were to leapfrog between boxes. That's one of the biggest threats. I read a paper from a cyber insurance company once that was, just discussing like what do they view as kind of the hurricane level events in cyber insurance. And one of the things they talk about was a hypervisor escape that would allow an attacker to jump from different instances within a cloud service provider. Whereas you might be one customer with your own instances, and then suddenly an attacker is able to go through the cloud service provider in order to get access to your instances there. That's one of the biggest scares for a lot of people.
Are CSPs providing customers access to infrastructural logs at all? And what does that access look like, if so? And how much is filtered before we get our hands on them?
Again, you have access to the logs about, the infrastructure that you're creating for yourself in terms of, instances you stand up or changes that you're making to the firewalls yourself. But you're only getting access to that level of information. You don't get access to any time a new rack is put into a data center somewhere in AWS's environment. You don't get access to, whenever new customers or anything like that is going to get put next to you, on, potentially the same system as you're just running in different VMs on that same system. You won't ever get access to any of that information.
Yeah, so do you have any idea of how much is actually getting filtered out before we get our hands on them?
I don't know. I mean, it really just comes down to looking and seeing like what information they're providing to you, which is again, just the actions that you're taking and, just making assumptions that there's a lot of other things happening behind the scenes. But again, hopefully like none of those things are going to impact you. Hopefully they've made the precautions necessary so that, if any of those changes do happen behind the scenes, that they aren't going to impact you. You do periodically have these events where, AWS makes or different cloud service providers make mistakes in potentially configuration changes that they're making or code updates that they make, and it ends up accidentally shutting down whole regions or shutting down availability zones in different ways. And again, a lot of them are pretty bad about updating customers in any way about that. You really only find out about it when something goes wrong and you're wondering why it happens, and you potentially check a status page or something like that, and you find out that that it's gone down. Some of the cloud service providers have been pretty bad about updating their own status pages, though. So you've had an incident a number of months ago where S3 went down US East 1 for everybody, and AWS never updated their status page for it, and everybody's like, it shows green, but clearly it is broken for everybody right now. So you do have those issues.
What happens with our data when we terminate our accounts with our provider or migrate to other providers?
So the data behind the scenes on most of the cloud service providers should all be zeroed out immediately after you terminate instances. There had in the early days of cloud, they hadn't been zeroing out this information, and there was some ghosting of different sorts of some of the prior customers' data. There was one cloud service provider that was unfortunately not taking that precaution. But nowadays they should all be zeroing out that information. Additionally, like I said earlier, with physical hard drives and things like that, once those hard drives come to an end of life, they have a process of destroying those before they even leave the data centers.
So are they zeroing out like sections of the disks or the entire disk?
It hopefully should be all of the useful data on there, but I don't know the specifics of how they're accomplishing it. In theory, this is a place where we just have to place our trust on them that they are zeroing out all the information. I
guess different customers will be sharing disks, right?
Correct. Yeah. So once you start up an instance, it's very unlikely that you are the first person to be running on that hardware. Chances are another customer has been there before you, and another customer will be there after you.
Yeah. So it'll be interesting to know whether they're actually zeroing out just your stuff, or whether they're not zeroing it out at all until all customers are off that particular disk.
Yeah.
Do we know who can view the data we store in the cloud? CSP employees? And what checks and controls do the major CSPs have in place to make sure that this data cannot be read or exfiltrated?
Yeah, so again, this is an area where I think most of the cloud providers will state that they're not giving access to their employees of any sort, being able to see any type of visibility. However, I would be surprised if they're not being able to see some, logging information, specifically things that as data is leaving your environment. For example, AWS will alert you if your systems start port scanning other systems out there on the internet. They'll tell you that one of your systems is potentially compromised, so they'll try and alert you of that. And they're doing that, not only because it's nice of them to let you know that a system's compromised, but also, they don't want to have, hack systems running in their environment, and deal with the potential repercussions of getting blacklisted by different services for that reason. So they will detect some of those things, but again, that's only going to be things that are happening as data is leaving your environment. So logging that they can see as network traffic is leaving out of the environment. They shouldn't be able to see what is actually running in your EC2 instances. They shouldn't be able to have access to memory dumps or anything like that. And we think that that's true just because there have been a lot of times when customers have asked for memory dumps of their systems, and AWS has responded that they're not capable of it, or different cloud service providers say they can't do that they have a lot of precautions in place, and so that's what kind of gives us the confidence that okay, they really don't have access, because in some cases it's very large customers that have a lot of money and very big support contracts where you think that the cloud service providers would be able to be able to go out of their way or change their rules a little bit for some of the large sums of money that some of these customers are potentially willing to throw around, and the cloud service provider still will not make any changes to those policies.
Okay. Are any CSPs standing out that I can think of that are doing a decent job of their responsibilities and helping potential customers understand where the lines of separation are in terms of the shared responsibility model?
I mean, I think all of the different cloud service providers do have some types of documents that they provide. So, AWS is the environment that I work with the most. And so, I read through a lot of their documents, and they have a document specifically about that shared responsibility model. And I imagine that the different the other cloud service providers, such as Microsoft Azure and Google Cloud and some of the others, that they're also providing those as well.
I see quite a bit of the documentation in that, but I'm just not sure how much of that's actually making it to the likes of the C-levels. Yeah.
And it always becomes a frustration that there potentially is a lot of this documentation out there, but it might be so overwhelming, or it might be kind of difficult to understand what are the right documents to read. A lot of AWS's documentation for their different services ends up being, hundreds of pages long. And so trying to find those nuggets of information that you're actually looking for in there can become difficult.
Is it a better idea to actually build this stuff into the interface? Because people just generally only read docs if they have to, right?
Yeah.
But they have to use the UI and the APIs and that sort of thing. Potentially building some information around this into those sort of interfaces. What are your thoughts around that?
Yeah, I mean, again, that's going to be a difficult usability problem to try and present the user with the things that they need to know, the things that they want to be able to do and learn and know about the product, but not overwhelm them and not make it just too difficult with too much text, too many buttons on there. We've all seen those interfaces where it's just overwhelming to you, especially as a beginner user. But then as you become a power user, some of those environments might not offer enough of the buttons, enough of the text, as you become more comfortable with those tools.
So we're just going to move into a bit of a section on the differences between cloud service providers and in-house. So what are some of the aspects that are more secure in the cloud than in-house? Can you think of any concrete examples?
As we've mentioned, taking care of a lot of the physical security, I think that the cloud service providers can do that a lot better than a lot of private entities can accomplish that themselves. It depends on what are the entities you're looking at. Are you looking at a mom and pop, or just a brand new startup that only has a couple of employees, or are you looking at potentially much larger company that has a much larger workforce and can accomplish those things. So especially for the small startups that only have a few employees, the cloud service providers are going to be able to accomplish a lot of these things a lot better than them. Specifically around things like having having, guards that are manning these centers 24/7 and having processes in place for all these different things, they're going to be able to accomplish that a lot better. Things like, segmentation of duties. If you only have, a company of 3 people, there's not a whole lot of segmentation of duties that you can really accomplish there. Whereas, once you have hundreds of employees, then you can start, splitting up those responsibilities in different ways better. But we have heard, that some of these cloud service providers, they do have, since they are bigger companies, they've hired a lot of experts in different fields, and those experts have different, friends in different areas that are doing research and friends in governments and things like that, potentially some of the cloud service providers are getting access to information about, things like vulnerabilities before potentially the larger public is getting access to some of those things.
CSPs are tasked with taking care of aspects such as just general infrastructure, hardware, hosting, continuously hardening components and infrastructure, patching components only visible to the CSP, network firewall routes and rules of the CSP's core infrastructure, network component logging, network intrusion detection systems, and regular penetration testing. Do those organisations contemplating in-house cloud solutions need to consider all of these aspects?
I mean, they still should. They still should undergo things like pen tests and things like that. Just because you do need to expose the different areas of your responsibility for security in those environments that aren't being handled by those different cloud service providers. So you should still have things like network intrusion detection. And part of this is because, the cloud service providers, they might be accomplishing some of these things, they might be performing some of these things, but they might not be giving you that visibility and insight into what they're finding. So, they might have, network intrusion detection of some sort, but it potentially is only going to be for their own systems, and it's not going to be detecting things for your systems. And they might have different levels in which they would inform you about these. So for example, I mentioned earlier about how they'll detect port scanning and be able to alert you about that. Well, it depends on when they're going to be alerting you about that. They might take a while to alert you. They might only alert you when someone else on the internet complains about it. They might not alert you as quickly, and they might not give you the specifics of the information that you need otherwise. So it still is very important to do things like the monitoring, to be able to do pen tests, to be able to do things like that across your environment.
So how can we be better prepared for CSPs being forced to give up our and our customers' data to governing authorities and others without our permission or even knowledge in many cases? Does this just come down to using more crypto, or what else can we do?
Yeah, so you do want to make sure, depending on, I guess, your views of different countries' governments, where your data is being held at. And so, you can ensure that it's being used and maintained only in specific countries' locations. So you can do that. But then additionally, your other fallback is going to have to be on things like encryption to try and protect that. But again, it's a very hard problem to ensure that the data that you have, on one of these cloud service providers, if you are keeping it in any type of unencrypted manner, because ultimately you want to be able to use that information there to try and ensure that it can't be, read by that cloud service provider in any way. Like it becomes a very hard problem. There's not really any good solutions to.
So I'm just moving on to a couple of questions around some other risks. CSPs provide many security enhancing services and features, most of which I see software developers and people above them in the org chart think of as inconveniences. How can we encourage developers and others to use the security features more security by default, or any other ideas?
I think one of the ways, it always helps to be able to present people with different checklists and be able to, give them scoring on how well they're doing in their environments. And so there's become a number of tools that you can run. They'll just do simple scans across your environment to look for certain, whether or not certain security features have been enabled, or whether or not there's been misconfigurations that have happened. So for example, it'll be able to detect, which of your users have multi-factor authentication enabled enabled for them, or whether or not you're using password complexity policies, so it can make some of those checks for you, or whether or not you have logging turned on, for example, the CloudTrail logs, or some of the other logging options that exist for AWS. So I think that's one of the ways in which you can go about that is run one of these tools, see what your output is from it, and then be able to present that to potentially management or others to be able to show them like, hey, look at we have a score on here, of 15 out of 20, and if we want to get the full 100% for our score, then we need to do these additional steps for ourselves.
Any thoughts or security concerns around serverless technologies that look new, or that as software engineers we need to be thinking about?
Again, there still are the risks that, behind the scenes, it still is, an operating system that exists out there in the world that potentially has different types of vulnerabilities in it. Your software itself, is going to still have different vulnerabilities in it potentially. And so you still have to be, mindful of these different things. I think a lot of people just assume that, as long as they're running it serverless, that, potentially it's going to run too quickly for an attacker to be able to exploit, because a lot of them can only run for maybe 5 minutes at a time. But an attacker can still maintain persistence in different ways in those environments, and attackers are getting better about being able to automate their own tools so that they can accomplish things in an automated fashion without having to be hands on keyboard as they're trying to attack different things. So I mean that's just kind of the biggest thing there is that it still is a lot of the same issues, but it's just changing how those things are going to get attacked in the future, and how you can try and defend against these things.
I'm trying to dig for some examples around some of the different serverless technologies and what we need to be thinking about. I mean, can you think of any examples?
Yeah, so I mean, there's like AWS has their Lambda service, which is going to be their serverless technology there. And with Lambda, usually what you're going to do is you're going to assign what's called an IAM role to those different functions that you've built up there. And those IAM roles allow you to take actions in the AWS environment. For example, it might give them the ability to read from an S3 bucket. It might give them some other types of capabilities. And with that IAM role, you can limit it down and you can restrict it to say only this one S3 bucket is the only one I want to be read from, and potentially only within this directory within that S3 bucket. However, a lot of people might misconfigure that IAM role and just give it access to all of the S3 buckets. It'd just be easier for them to just say S3 star is the privilege that you give it, and so that gives it access to all the S3 buckets. And that also gives them the ability to read, to write, potentially delete information in there. And so that's that's one of the concerns there is if that serverless function was exploited, then the attacker has those full privileges to attack all of those different things. Additionally, a lot of your serverless code is going to be like your other code that you have, in which case you have different secrets in that code that you need to manage correctly. And so these secrets are going to be things like API keys or potentially passwords, things like that, to give them access to different databases or other services that exist out there. And so you still need to be able to protect those different secrets. And so that, because again, if that technology was exploited in some way, the attacker would have access to those secrets. So, you need to make sure that you're protecting those, that you're able to roll those quickly if they ever do get compromised. So those become all of the different, difficulties that you have. It's really a lot of the same ones, but it's just, applied in a slightly different way.
If you're a software engineer and are you working away at one of these serverless technologies or anything basically in the cloud, it's just like, right, let's get it working right, and we'll work about think about how we're going to secure it later. So a lot of the time these things actually get neglected, and they get left quite open.
Exactly. And so that becomes where it's important to audit, what those different, IAM policies that have been applied to these different resources are. And using the CloudTrail logs that we mentioned earlier, you can start using those logs additionally with the policy that exists currently to understand what of the capabilities that resource has that it's actually using or not using, and therefore start, trimming it down and restricting in different ways. So, by looking at the CloudTrail logs, you could see, oh, hey, it's only ever using, this one S3 bucket. Therefore, I should restrict it down to only accessing that one bucket and not give it access to all buckets.
Can you think of any of the features that AWS, for example, provide to help us with secrets and storage of secrets?
Yeah, so there is a service called KMS that AWS provides, which is a key management system, and there's been some open source projects that are built on top of that. For example, CredStash uses KMS, but then AWS also has, I think it's called SSM is the name of their service, which is essentially CredStash, but just kind of a managed version that AWS is providing to you. And so what these allow you to do is this allows you to when you give an IAM role to a different resource, for example, your Lambda function, what you can do is you can tell it, okay, you can access, this key, this, one secret. And so it can access that, but then your other functions cannot also access that same secret. So you can divvy this up and break it up into different ways so that some functions can access some secrets and some can access others. And so that's really the power that one of the services that the different cloud providers can offer to you.
Yeah, so it's coming back to the least privilege concept and defense in depth, isn't it?
Exactly, yeah. And I mean, the biggest benefit of doing this type of thing is keeping those secrets outside of code, where, the code potentially could get leaked, or the code at least, a lot of companies have just one single repo of code that they're sharing across all of their developers. And so, if you have 100 developers, all your 100 developers are going to have access to that code. And chances are, unfortunately, one of those developers is going to upload all that code to GitHub at some point. Or you might have a contractor and you're going to end up, that they might do it by accident, or, someone might get compromised. One of their laptops gets compromised, and now, the attacker has access to that data there. I think a lot of people don't realize that, especially source code ends up getting shared probably more widely than people expect it to. Anytime that you need to do any type of audit or something like that, chances are you might end up having to share your source code with some other third party in some way. And so you want to make sure those secrets are not being held in that source code as you potentially hand it off to somebody.
Yeah, it's more a matter of when rather than if, isn't it?
Exactly, yeah.
So you created FLAWS as a free online capture the flag tutorial to help recognize common misconfigurations and gotchas in AWS. Can you talk a little bit more about this?
Yeah, so this was about a year ago that I created it, and it was really I was running a company's security at the time. We had a DevOps guy, we had some developers, and I wanted to provide them some training on some of the potential gotchas in an AWS environment. And so these were things like S3 buckets that have been exposed, or one thing that a lot of people aren't aware of is there's kind of a magic IP address in the different cloud service providers that's 169.254.169.254, and if you can access that, you can get credentials for that resource that can basically take over the IAM role of that service. And so this has happened in the past where people would run some type of proxy service on AWS, and it would end up someone would use that proxy service to access that magic IP address and get those credentials, or in various other ways people have accessed that IP address. And so that was another one of the levels in FLAWS. And so this is what I wanted to do, is just kind of show my own developers, my own team, what are some of the concerns that we have. And I looked through HackerOne and other repositories of bug bounties and things like that to try and identify different ways that companies have either been hacked or had bug bounties awarded against them, and so looked up those things and basically built up kind of a game that had you actually perform those attacks. So you could actually see what it looks like from the attacker's perspective and see honestly how easy some of these attacks are to perform when things are misconfigured like like this. And so with that, was able to show, my team what those different problems are, and included in there for every single level, basically gave, hints along the way that describe, how this is happening. And then at the end of the level, I basically say, this is what the misconfiguration was. Here's some examples of, companies that had this misconfiguration, and be able to give that information to people so they're better aware of those issues. And I figured as long as I was releasing it, for my own team, I was able to do it in such a way that I could release it publicly to people, so others could play along with it. And so it's free at flaws.cloud. You can access it, you can play it anytime, and be able to go through. And if you don't want to actually be hands-on keyboard and actually perform the attacks yourself, you can just click through the hints, and it'll be able to click through one level to the next level without actually having to do anything yourself. And so it's been I've received a lot of feedback from people, both on Twitter and emails, where people have said it's been useful, that they've trained their team with it, that it might be college students or something that were learning AWS for the first time, and they've used that to try and learn some of the things about AWS before they started actually using the services, so they were prepared for potential mistakes that they might make in that environment. And so in the first month, like 30,000 people had already visited the site, and so it was way bigger than I ever expected, like for something that is as niche as AWS security. I didn't expect as much positive responses from people, or as many people just seeing it as actually did.
Yeah, that's awesome. Hey, how many levels does it have?
I think it's 6 levels. The first couple are going to be related to S3 buckets, and then it gets into some of the other different issues that can occur.
Yeah, cool. You were on the Purple Squad security podcast recently discussing detecting intruders on AWS. Can you give us a bit of a rundown on what was discussed?
Yeah, so on that podcast, I discussed, basically some of the different ways, some of the different logs that exist on AWS, and, some of the ways you can collect and monitor that information, and what to look for, more specifically in there. And really it comes down to, being able to look for access denieds when you have implemented least privileges across your environment. One of the things that I did with FLAWS was I was not only releasing it as kind of a tutorial to my own employees, but one of the reasons I released it publicly was I was using it more or less as like a honeypot to be able to see what does it look like when someone tries to attack an environment. Because in FLAWS, what I'm doing is I'm giving random people on the internet access keys to my AWS environment. So they actually have credentials of some sort. They're very restricted, so they can't do anything that impacts the game. They're not able to run EC2 instances to mine Bitcoin or anything like that in my environment. So I'm not being charged a bunch of money for it. But with it, I was able to look in the logs and see what are the types of different things that they're doing, and try and look for things of interest in there. So one thing that I thought was somewhat interesting was just that of people that actually like played the game, hands on keyboard, actually were using the command line against it. There were about 1,000 people that really weren't just clicking through the web tutorial, but were actually playing the game. And of those 1,000 people, there were about 1,000 different user agents of their tools when they were hitting my services. And so I thought that was really interesting. So these aren't browser user agents, these are the command lines user agents. So it's going to be like AWS CLI, and it's going to give you the Linux version that they're using, or if they happen to be on Windows or some other operating system. So it's somewhat similar to your browser CLI, but it gives you the version of Python that's being used by the CLI and some things like that. And so I thought that was, it's not really a good detection, but that was a thing of interest from the tool. I've also leaked a number of keys onto services like GitHub and Pastebin, things like that, just to see like what happens when an attacker tries to get access to those. And in cases like that, a lot of times they're using Tor or some other type of proxy in order to access your services. And so that's the thing to look for, is to see, is someone using Tor with your access keys? Chances are your real developers and your real DevOps guys aren't using Tor when they're doing real work. And so that's a thing that you can look for. And AWS actually just recently at their conference, they released a new service called Guard Duty. And so this service it's just $4 a month, which is pretty cheap. And that'll actually look for things such as service keys using that are being accessed from behind Tor nodes.
Okay, cool. You also wrote an article recently on potential gaps in suggested Amazon Web Services security policies for MFA. What goodness do you have to share with our listeners from this?
Yeah, so this was, I was working with a client, and so in this case it happened to be Duo Security that I was working with, and so discovered kind of an issue with a policy that AWS had in that they had posted online that they had been advocating to their customers for a while, and this was a policy that was supposed to enforce multi-factor authentication on the different users of an AWS environment. And so, the thought is that you turn on MFA, but AWS doesn't actually enforce MFA when it's being used for access keys. So even if you have an MFA device, it's not actually going to require you to use that. And so what this policy does is it requires the user to actually use that. And it was supposed to have some I guess, gaps in it in order to allow a user to be able to change their password, be able to change their MFA device that they got a new one, and be able to do some things like that. And so, which is really useful for things like onboarding. You don't want to have one administrator helping people change their password every time they want to change it or anything like that. So it was supposed to help with that, but unfortunately it had some what can best be described as vulnerabilities in it. And so what these would allow an attacker to do is, if they did compromise someone's access keys, and those access keys were supposed to have this policy on it to require an MFA device, what the attacker could do is they could actually use one of the gaps in the policy to remove the MFA device that currently exists by the user and add in an attacker's own MFA device. And so they could add in their own MFA device. Now that there is an MFA device associated with that customer, the attacker can then make use of whatever other privileges they had, because then they can just punch in the code for that MFA device, because the attacker owns that MFA device now. So that was really the big thing, was it was allowing you to just completely bypass their multi-factor authentication policy. And this had escaped a lot of people over the years, and AWS themselves had put up that policy. And so what I was able to do with my client was, work with the AWS security team in order to get it fixed, and they sent out emails to their different customers to inform their customers, that this change had been made to make them aware of these problems that had existed with it. So that was an interesting experience, and we ended up putting up a blog post about that afterwards.
Yeah, nice. I've got links to all these in the show notes as well. I know of and have documented a little bit Security Monkey in the cloud chapter of my second book. For the listeners, can you talk a bit about Security Monkey and also Airbnb's StreamAlert?
Yeah, so these are two pretty separate tools that are each helping you mostly with your AWS environment. So Security Monkey nowadays also works with Google Cloud in order to be able to detect issues with that, and I think they're also trying to expand it to misconfigurations beyond just cloud service offerings, but also things like if you have a GitHub Enterprise, they're also putting in some checks there in order to be able to detect misconfigurations there. But what Security Monkey does is, this was a tool released by Netflix a number of years ago, and a lot of people that do DevOps work might be familiar with things like Chaos Monkey, which was another Netflix tool which would go ahead and kill different instances to ensure that you had that availability, that things would restart automatically for you. But what Security Monkey does is, this is another project of theirs, and it will actually go ahead and check different AWS environments that you have, and it'll look for things like exposed S3 buckets or IAM policies that are very permissive and allow a lot of things, or access keys that haven't been rolled in over 90 days, or all sorts of different checks. I think at this point, I imagine there's at least dozens of checks in there, if not 100 checks. There's tons of different things that and they're adding to it all the time. So it's a very active project still. And what this does is it's running continuously. And so every single hour it's making these checks. And it can email you when it finds new things, and it can show you a diff. It can also, be able to show you all of the currently open issues that haven't been justified yet. But so that's the other thing that it does. It provides you a whole web UI that you can log into. You can search through and find all these issues, and you can go ahead and justify them. And it does, allow some role-based access control where you could have some people that only have viewing permissions, and some people that have the ability to comment on issues, and some people that have the ability to actually justify those issues and close them out. And so that's a great tool that's been around for a while and is phenomenal for being able to detect all sorts of issues in an environment. And so there are some other tools that are more geared towards, pen testers that are going to be like a one-time scan. And so this would be a tool like Prowler is an example of that. And it just will do a one-time scan and it'll give you, that report. Whereas what Security Monkey is doing is it's just continuously running in your environment and being able to detect things. And so that's a great tool. And then StreamAlert, what it does is it's monitoring your logs, and I've used it primarily for things like monitoring CloudTrail logs, but it can be used against any type of logging service. And so, Airbnb, they built it originally, for their web server logs and just all of the logs that they had coming in. And StreamAlert is very focused on AWS, and so it's using Kinesis and it's using some Lambdas, and some other services of AWS, and so it very much ties you into that environment. So you're not going to want to use StreamAlert for Microsoft Azure or Google Cloud or anything like that. So it ties you into that environment. But because it's serverless and it's taking advantage of the things that AWS is providing, it's able to work as basically a SIM that just scales infinitely for you, and you don't have to manage it. You don't have to try and keep up with it too much. There's a little bit of care and feeding that you might have to do, especially as you start using it more aggressively and more heavily. But it's very hands off, and it's able to work very quickly on things as well. And so that's a great tool, and that's all basically all of your alerts or detections for things it all exists as code that you check into your own Git repo. And so with that, you're able to have a history of why you created this rule and exactly what that rule is, and any comments that you want to include in that, and who created that rule. And so it's a great tool from that perspective, and that's really moving you in the direction of using basically Git to maintain your whole detections and monitoring and alerting framework. And that has a lot of benefits to it. And so that's a great example of a tool that allows you to do that.
Cool. Do you have any interesting personal projects or events that you've got on the go currently, Scott?
I do actually. For a client right now, I'm working on a tool to visualize AWS environments. And so this would be a tool that would allow you to basically see the different EC2 instances and what security groups, what network accesses are available between security groups. And so this is a project that we'll be open sourcing here pretty soon because I'm doing a collaboration with a client. And so that's going to be awesome, and we have plans of taking it a step further in the future, because there are some tools that exist out there on the market that are commercial tools that allow you to visualize things like this. But we have plans to also take it and be able to visualize some of your IAM permissions that you have. So as we mentioned earlier about Lambdas that have access to all of your S3 buckets, even though you might have the expectation that it only has access to one or two buckets, this tool will be able to help you visualize and see that. And I think we've already discovered, as we've been using the tool, it's really helped us understand the environment of my client a lot better, because now it's not only as code, it's not just a web UI, that they're clicking around in the AWS console and they're trying to read text in order to understand their environment. Now it's actually visually representing it for them.
Yeah, so when's that going to be open source, Scott?
That should be in the next, hopefully, few weeks. We'll see how, we still have to try and test it out and make sure it's ready for a more public audience. But I would imagine probably sometime in January.
Cool. So due to time shifting, we may or may not get that link into the show notes.
Okay. Yeah.
Okay. So what have we not discussed that we really should have discussed? Can you think of anything?
No, I'm good.
Scott, thanks for joining us today. It's been educational and fun.
Yeah, thank you for having me. This has been great.
For Software Engineering Radio, this was Kim Carter.
Listen up, software engineers. When was the last time you proposed a product change that was really listened to? How often does your code ship to production? Same day, within minutes? When was the last time you actually wanted to go to work? At Ultimate Software, this could be your new normal. And with offices in Florida, Georgia, and California, what are you waiting for? Visit ultimatesoftware.com/careers today and start making a difference tomorrow. Ultimate Software. People first.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.